Being at CppCon has been amazing because you can directly speak with the experts. I've had conversations with Bjorn Strusepp, with Sean Parent, and they're all very friendly and accessible and willing to give their opinions or advice on C++.
All right, welcome everybody. My name is Jeff Garland. For those who have not met me, I am the assistant chair of the library working group, so I spend most of my time on the committee looking at library features. But today I will talk about all the features in C++26. Well, we'll see about that. It's a 1-hour presentation after all, so decisions will have to be made. If you're, oh, you can't see on that particular display. Oh yes, maybe you can. There's about 90 slides here. Some of those are transitional, but there's actually a lot of material here. One other thing I'll say is the PDF that comes along with this talk will have all of the links for the godbolts, the examples, the papers, and so forth. So don't try and scribble all that stuff down while you're sitting here. Just get the PDF afterwards, and hopefully this tutorial or this talk will be sort of your intro starting place for going to look at features of C++26 that you're interested in. Yes?
Will the PDF be posted on Discord?
The question was, will the PDF be posted on Discord? And the answer is yes. And I think we want people to come to the mics in general. I will say what I want to do with this talk, because we do have a lot of material and I'm going to go pretty fast, is probably after each little section I'll take questions so we don't get too far ahead of things. Okay, so who in the room is familiar with how the Standards Committee works? Quite a few people, but actually not so many people. So the reality of C++26 is it's going to ship in C++ in 26, regardless of what ISO does. ISO is their own little thing, but the idea behind this has been ever since 2011, where there were very long delays in the process. Herb Sutter and probably some of his friends came up with the idea of the train model, which is to say, if your feature is at the station when the train is leaving, it will be on the train. If it's not ready, then it will have to wait for the next train. It's that simple. So things that I'm going to talk about today are largely already in the working draft for C++26. We've been working on C++26 now for an extended period of time, really since February of 2022, when that was really the last C++23 design meeting. In one way or another, we've been working on it since then. So the 2026 schedule is the design freeze is February of next year. So we are just months away from the design freeze. So we have a pretty good idea of the shape of what's going to be in C++26. There will be a lot of things on the bubble. Certainly something I talk about today won't get in. Even something that's written in the working draft can be ripped out, even at the last minute. That has happened before. It happened to concepts. It happened to contracts. So take everything here with an understanding that, it may not actually be realized in 26. But the other half of this is that once something goes in the working draft, basically vendors will start to implement it. And so you'll actually see that many of the features that I'm going to talk about today are actually available in compilers right now. So you can go get some of these features, not everything. So the final approval will be late in 2026. Hopefully that ISO part of it will be the case. So what were the priorities? And don't get scared if you're working on contracts and in this room, because we don't know what's going to happen with contracts. I just crossed it out there because it's looking a little iffy right now whether contracts is going to make it. Pattern matching, I can tell you, probably won't make it. Networking for sure won't make it. There's a bunch of things that the committee, which, by the way, we do have a paper that outlines a rough plan for what we're trying to do in each release. Those are very high-level guidelines, and most of the features I'm going to talk about today wouldn't appear in that paper itself. But the interesting thing about what I'm going to talk about today, I think, is that these are things that are going to matter for you guys every day. Some of these features, there are a ton of things in the standard library, in case you've used it, that are little edges that are not really helpful to programmers. And so we'll talk about a lot of those. Concurrency, standard execution, that's P2300. That has been voted in now. So you should expect that. We were just talking about this before the start of this presentation. 2300 as it is, without some of the follow-on papers, is a little bit of a hollow shell. So we're hoping that a lot of the follow-on papers are actually going to land so that 2300 and standard execution will be complete. It's a huge feature. It took us a year and a half to review the wording for it, more like 2 years, spread over many, many meetings and lots of time. So that's a big change that is coming, and something that I'm only going to peripherally talk about. And you'll see in a minute, what are the priorities for this talk? And for this talk, my focus is going to be mostly on smaller things that I can do at a faster rate to give you the entire arc of what's in C++26. Things like reflection and P2300, contracts. These are 1 hour talks, not even 1 hour talks. They're 1.5 hour talks all by themselves. So in 1 hour, there's absolutely no way I can do those things justice. I do have some slides in the deck associated with those features, and those will be in the PDF. So you will have a starting place to go look if you want to learn what's going on in some of those features. There's a lot of other things though. So new collections, new range things, other small language features that you can apply in various contexts. Okay, so generally the outline of this talk, I'm going to cover a couple of sections that have both language and library features, where there's a handful of things that kind of go together. So debugging features that you can use. And these are at the top of the presentation, actually, because these are like tiny things that are probably some of the most important things you'll be able to use. And I think a lot of them are actually already supported. Structured bindings. Who uses that feature? Anybody in this room? Seems like it's pretty popular. There's a lot of changes that are coming to structured bindings that allow you to do some fun things. There's changes in templates, and there's a few miscellaneous things I'll talk about. And then the library. There's just a ton of things in the library. String processing format, new containers, ranges, as I said, but there's things for support of math in general. Linear algebra. Who would use linear algebra in this room? I'm actually impressed. There's about 25 or 30 people in the room. That's pretty good. Again, a subject that's way too large to talk about, in a 1 hour presentation. SIMD. Who's interested in SIMD stuff? A lot of people in this room are interested in SIMD. That's another one that I'm not going to talk about. There are slides in the deck. The concurrency, that's P2300. There's a couple of other features there, also in the deck of slides. And by the way, if we actually do finish early, we can take an audience vote and go back and cover one of those subjects. Okay. So the first section here is language and library. The first topic is debugging. So there's a number of small useful things that are being added here. The first paper basically adds to static assert the ability for you to put in a build time diagnostic. Why would you do this? If you're enforcing an API constraints or something with a static assert, it's nice to give the user a nice error message. You'll notice here, I actually have std format here, so we expect to be able to do compile time formatting so that you can get a very nice and useful error message to your users when they violate the contract. Okay, so that's a very simple feature. The second one here is a related feature. This one has to do with delete. So does anybody use the delete on member functions? Yeah, we got a lot of usage. So those were introduced, or initially introduced, delete and default were introduced in C++11. And they joined one other thing that used to be there since 98, which is equals 0, right? To say, oh, this is a pure virtual function. So default and delete have a different meaning, and but those appeared, but there was nothing there other than, say, putting a comment in the code to let you know why this was deleted. So the user intent was not there. So this feature simply allows you, this one simply allows you, if I go, let me go back here. So if you look at the bottom of this slide, those are your standard kind of deletes that you would do where you're deleting a particular function from overload resolution, for example. So that bottom example, you don't want the ref R value to bind if there's going to be a dangling reference as part of this API. So that's basically the idea is, like with static assert, you can now put a user message there which says, here's the reason why this is deleted. And if your user calls it, the compiler will nicely emit that. Do you have a question over here?
Does it have to be the array characters, or can it be created and used to format?
The question is, can it be created dynamically with std format? I don't know. I don't think so. I haven't seen an example of that in the paper or otherwise. So something to follow up on. But there's one other little interesting thing on this slide. If you look at those top two things, notice what's deleted there. That's a free function. That's just a function definition. So it turns out with this facility, you can also just say deleted to a function. It doesn't have to be a member function or a special member function like the equal delete of past. So again, very useful for maybe deprecating. Of course, we have annotations for deprecation as well, but maybe once you finally delete it, you can say delete, leave it in, and your user will get a good error message when they try to compile their code. Okay. The next one is on a related track, the assert macro. So the assert macro is on the library side. That's why it's grouped in this section of library changes and language changes. And of course, assert is a legacy thing that goes all the way back to C. But this has actually been changed for both in a way that actually, again, allows a user-specified error message. So the main takeaway from these first three things is compile time, error messages to users can be improved when you create a library and an interface. Now we're going to transition to another library, a new library feature, which is literally about the debugger. There have been in compilers and libraries, mostly in compilers, with intrinsics, the capability to invoke the debugger. So sometimes in certain contexts, you might find it handy to be able to say, I actually just want to write some code that inserts a breakpoint right here. And if I'm in the debugger, it will actually stop me here. If I'm not in the debugger, it will basically have no effect. So that's basically what this facility is. It was not something that you could do portably in the past. You would have to macroize it with the proper intrinsics across various compilers and so forth. So there's a new header here called debugger that you have to include. There's a couple of different papers that talk about the entire facility. There's a lot of hand waving that goes on in this particular thing about exactly how the platform implements that, and that's because different platforms may do slightly different things in how they actually implement this. There's some other utility functions here, like is debugger present, which allows you to do conditional logic on a Boolean, basically associated with whether or not the debugger is actually active. Okay, how are we feeling so far? Any more questions about that set of things? All right, let's roll on. So the next area is structured bindings. And again, there's a number of small features here that, add up to, an addition of capability that's, kind of interesting. So the first one here is structured binding declaration as a condition. So if you look at the first 8 lines of code on the slide there, what you'll see basically is that in using something like the toChars interface, by the way, who uses toChars in the room? Not so many. Yeah, it has a pretty horrible interface, right? This string handling and toChars and toString and all these numeric conversion things seems to be something that the committee has really struggled mightily with making a good API for. I'm hopeful that in 29 we'll actually land one. But in any case, there are some little revisions here, and as noted on the first comment here, P2497, which I'll talk about actually on a later slide, updates the toChars interface in a way that allows line 2 to actually work. Previously, if you use the toChars interface, there's an error code. You have to check and see the error code. So it's a very C-style interface with raw pointers. Again, not recommended. I just tell everybody, please wrap it in your own code that does better error handling and more correct error handling. So in terms of the structured binding part, you'll notice that the result in the conditional there prior to this feature meant that you would have to test the result in the if, and then you would have to unstructure the actual elements independently. So you had to write a second line of code which would take the result and unstructure the pointer and the error code, which are part of the return signature. In this new world, you will be able to write line 11 and it will just work. So it will check the error condition, the Boolean condition, and if it fails, you will not have the 2 in the error code actually structured. So it separates the two things. The condition is checked first. This also works with while loops and for loops, so it's broadly applicable.
Excuse me, is the resolution left to right or right to left on line 11?
The question is the resolution left to right or right to left? I'm not sure I understand the question.
Does it pick the value of the pointer or the error code to decide the Boolean?
I'm going to show you, I'll show you on a later slide exactly what's going on here, but basically what's going on is toChars has a structure return. That structure return can explicitly convert to Boolean, which is why the if condition works. Okay, so, but that's the long and the short of why it works. Okay, so the next change is not exactly a structured binding change, but structured bindings is one of the places that you're going to want to use this placeholder with no name. And like a lot of other languages, basically the decision was to use the underscore. So if you look at the code on line 2 there, right now with something like lockguard, you have to give the variable a name, even though you're not likely to interact with the lockguard in any way, except for putting it in a scope so that when it destructs, it will actually just unlock the mutex. So on the right-hand side there, we're just using the underscore character, and you can't actually use the underscore for anything. You can't actually use that variable. So you won't accidentally make a mistake of trying to do something with it. In a structured binding, it would look something like this, where you have some set of the variables that are coming back from the API that you don't actually care about. You only care about the first 2 variables in this particular thing. So that's another nice feature. It removes clutter from your code, right? Names that don't mean anything and actually aren't used anywhere else. So those are so it's valuable from that point of view, and it's very concise. Okay. The next feature for structured bindings is actually being able to apply an attribute to one member of a structured binding. So coincidentally, this is just another way to do something that we just did on the last slide. which in this particular case on the second line here, and I see I lost my line numbers here, but and I can't highlight it for you that easily, but in the second line where we're destructuring, we have the maybe unused, and the only weird thing about this is the attribute goes on what you might consider to be the opposite side of what you would expect. So it goes to the right of the actual variable declaration instead of to the left, which would be the normal thing that you would see on line 1. So in any case, there are, of course, many other attributes that might apply, that could be used in that context. So that's another enhancement to what you can actually do with structured bindings. And then this last item is not a language feature, it's a library feature. So one of those rough edges I was mentioning is complex. If you wanted to get the real and the imaginary value out of a complex, line 3 is the code you're currently writing, or you're calling independently. You can't just destructure it into independent variables like you'd like to. Nobody should be writing line 3 for sure. So with this tuple protocol, as they call it, so it's basically complex now can return something that looks like a tuple so it can work with structured binding effectively. So again, small things that take away rough edges. All right. Any questions about that?
Is the underscore allowed to be presented multiple times in the same scope?
Yeah, so the question is the underscore allowed to be presented multiple times in the same scope? Now, when I presented this talk in May, I was pretty convinced that it was. And then I was looking at some things, and to be honest with you, I now don't know the answer. And so we're going to have to try it out with an implementation. My understanding of the intent is it should be allowed. So if you had a structured binding where you had 2, you would be allowed to put underscore twice. And I think that's what the answer is going to be. But there was another, again, stuff on the internet, so you never know. Let's go back here first.
In the example where you showed that 2 chars could return a thing that converts to bool,
Mm-hmm.
and destructure happens after the comparison, you didn't have an else case.
I didn't.
The error handling work in that example.
Hold on to that because I do actually have a slide for that. Yeah, up here.
I was just going to clarify about the underscore thing. So you can use it multiple times in the same scope. The weird edge case is that if you make something called underscore and then interact with it, suddenly like the behavior goes away or something.
I don't think you can interact with it, so that's the other half of it.
There's macros and unit testing frameworks that rely on. There is a weird thing there.
Okay, all right. So the commentary is there's weird things. This is C++. Thanks very much. All right. Just use it, for the basic things and everything will be fine. All right, so a couple of other features. This P2558, I don't know how much this is going to affect people on a day in, day out basis, but effectively this is going to add some characters, to the basic character set. C23 is also doing something similar. This next one actually is very interesting. Static storage and braced initializing. So does anybody know what's really happening on line 1 there? I know somebody does, yeah, in front here.
You're creating an initializer list and then doing a construction based on the initializer list?
Right, and when is that happening? Is it happening at compile time or runtime? It's at runtime, right, exactly. Even though the compiler has all the information that it needs right there, right, to do that, it actually has to make an allocation at runtime to do this, which is really an unfortunate thing when all the information is well known. So basically the idea of the static storage for the braced initializer is the compiler can just make the storage and the vector can just use it, so there's no copying, there's no runtime impact. So it's a performance enhancement essentially. Now, for line 1 there, it's probably not going to be too important. Now, embed, which is a thing that we don't actually necessarily have, but embed, the idea behind that is I can take a data file and I can embed that into a source file with this macro. There's a C++ version of it that's called std embed. It's not going to be in 26, but in any case, imagine if you had to copy this, 2 megabyte image file that's some resource or some other resource that you're using that you don't want to allocate at runtime. If you're in embedded world, you might have some data structures or something that you want to have in memory, and you'd like them to just be initialized directly. So there's some actual real uses to this. Okay, so that's the miscellaneous stuff. Let's talk about templates. Pack indexing. So who's used variadic templates? Man, wow, I'm impressed. I have to say, variadic templates, I think, took a little while to catch on, but there's a lot of uses. Now, if you've ever tried to actually do something where you index, like this top line of code is doing, well, this top line of code is the New World Order. You're actually going to be able to use square brackets to index into into the variadic pack, and that's extremely nice compared to the meta programming hoops and other things that you had to do previously to achieve the same goal. So it's achievable now, but it doesn't look nearly as nice as what's on this slide. Also then, you can see in this particular case, I'm static asserting effectively on the first and last. And so in this particular case, it's taking 1 and 10 and adding it together. Of course, all of this is going to have to be evaluatable in const eval time. All right, so the next one is a paper that comes from another paper, which is related to what's called universal template parameters. And so this paper was split off to get something going sooner than later. So, who uses template parameters? I swear we're going to get down to a smaller audience. Wow, there's so many people that are using these advanced things. It's really interesting to see. But one of the things you can't currently do with a template parameter is pass a concept or pass a variable template, both of which would be useful in certain contexts to do. Now, the example that's on this slide is sort of a toy example, but it does come from the paper to demonstrate the concept. So the first parameter to the template, the structure there is a concept. So it's expecting to see a concept, and the second one is expecting to see a variable template. So if I create a concept here, this is, of course, the simplest possible concept you can create. And I create a variable template. In this particular case, I can now instantiate the structure itself with the concept and the variable. So again, smoothing rough edges in the type system to allow you to do more sophisticated things, especially on the concept side. There's some really valuable capabilities that allows you to do, allows you to lift to a higher level of abstraction certain kinds of things, reuse pieces. If you look at the standard library concepts, you'll see there's a lot of repetition in some of those concepts having to do with, copyability or movability and so on and so forth. And this facility of allowing the concept to be passed as a template parameter can eliminate some of that by allowing you to create a higher level abstraction. Okay. The next item is variadic friends. Notice a lot of variadic discussion here. And is Jody in the room? I don't think Jody's in the room today. But he is at the conference. He's responsible for this particular feature. So right now, today, if you wanted to have a friend of a template, so a class that's a friend of a template, you basically have to list them linearly. There's just no way to actually do this with a variadic at all. And so there's some design patterns where you might want to have a template that opts in, for example, a variadic list of types that can be friends. And so basically that's what this feature does. So now you can say friend T's, your basically your pack, and all of the ones in the pack will become friends. Now, mind you, if you're thinking you can say T's and they'll all become member variables, that doesn't work. That's something that I know some people are trying to also create but it's not something that you can do in C++26. Okay. Any more on that section? Contracts, I promised you I would skip. Reflection, I promised you I would skip. Let's move on to the library. We're at 30 minutes, so we're just on time. So the first set of topics here is, again, small changes that will make your life better related to string processing. So, string streams and string view. Why can't you construct a string stream from a string view? Well, because we never put that interface in. So what? You have to convert it into a string to do that. So again, this is a very straightforward feature. It basically creates constructors that allow you to construct a string stream from a string view. So in this particular case, if you look at line 2, this is talking about, applicability that's beyond just, the obvious thing in the standard library. Let's say you have your own string type, or you have a boost string or a static string size or something like that. And that thing is convertible to a string view. Well, those string types will now just work with string streams and string views. So, and you won't have to create a full STD string and do a copy. So again, small efficiencies and small API change. This next one is sort of the opposite direction, which is to say that on standard string right now, you can call substring, right, and give it to an index, a single index, and it will go to the end, or a double index, and it will give you that content within that. But you have no way to actually get a string view out of that. Now, I'm going to date myself here by telling you that at the beginning of my C++ career, I used something called RogueWave. And they had a RogueWave C string that had the equivalent of the string view. And indeed, you could do a substring on a string and get a string view out. This doesn't come without its own issues, of course, because the string view is basically a pointer and a count, right, into the memory of that string. So you can't let the string go out of scope. But there's a lot of very good use cases where that's not a problem at all. And you just have to be aware of the fact that your string view is doing that. So the method is called subview, and it has the same variance as the substring, and it just won't make a copy. So imagine if you're parsing and you wanted to, create a collection of things, this would be a very efficient way to do something along those lines. The next one, yet another, small edge in the standard library. I can't just take a string and add a string view to it. That is a compile error because the interface doesn't exist for that. Okay, fine. So I can construct a standard string for the view, but that means I got to make a copy, right? So I've got an efficiency problem. Or I can call view.data, but that's a disaster. Actually, it's undefined behavior because string view is not guaranteed to have a null ending. So don't do that. Definitely don't do that. Wait for this feature and it'll just work. Line 5 will just work and it'll be fine. So again, it's another thing that, when string and string view were originally put in the standard, or when string view was originally put in the standard, there was a discussion about putting this capability in, but they didn't do it at the time because they were afraid there were going to be issues with the interfaces. So it turns out it's all fine, and it'll be in C++26. All right, here's another one. Who uses bitset? Interesting. So bitset is one of the oldest things and is actually a pretty handy thing in certain contexts. But if you know anything about bitset, it's mostly constructed from strings, or it's constructible certainly from a string, but once again, not a string view. So this just adds that capability as well. Okay, so I promised I would go back to the charconf conversation and show you a little bit about this. So as mentioned in the previous slide was dependent on the API change that's here. So the two highlighted lines of code there, this is what the struct looks like. It's got, a couple of data members. One is a pointer to the last index where the char comp, where your two chars function ended. And then there's an error code, which tells you whether or not the thing you were trying to convert actually met the requirements. So in other words, if you, for example, are trying to do two chars on something that is definitely not capable of doing that, you will get an error in the error code. Well, this is very inconvenient to actually utilize. So basically, what it looks like before is you have to do the structured binding like this, and then you have to compare against the default constructed version of the error code. It's very non-intuitive code. As I said, this API leaves a lot to be desired. And so what's happened is this explicit operator to bool, which basically encapsulates that little tiny line of code, has been created there. So now when you put it in an if condition, that explicit conversion to bool will be triggered, and in fact, you won't have to write that. So now, after this change, if I'm not using the structured binding part of it, I can just say what's on line 13 and 14, if result, then go get the pointer or whatever I need to do from there. So I don't actually need to use the error code member of this struct anymore, which is nice. And then with the other structured binding feature, it turns out they all work beautifully together. And so your error path can handle it. Now, the question was, what about the other path, right? The else path. And the answer is that if you need that, you're going to have to get, the error code. You're probably not going to use any of that structure when there's an error, except maybe for the pointer, but even there, it's very questionable whether you'll actually end up using it. So you're not going to have the destructured elements if that fails in the else block. That's the answer to the question. If you need it, you can still get it, but you'll have to write your code in a different way. Okay. So next one. And this one's really interesting because don't let anybody tell you that the C++ committee is unwilling to break your code, because we are going to break your code if you use toString. Who uses toString? Too many of you are using toString. You probably should not be using toString, especially if you're using it on floating point values. It is seriously broken for floating point values. So I'll just leave it to you to read the details in the paper, but precision is a serious problem with toString. There's confusion about how the locales work and so on and so forth. So the paper did an actual analysis of open source. They actually tried to go look and see where toString was mostly being used. Mostly toString apparently is used in low stakes places, because probably anybody that's got high stake precision values learned right away that the API doesn't work properly. But it's used in logging, and those kind of logging results could also throw you off, right? But, so what is the change here? Well, the change here is to basically make toString use the from chars half of that API, which is what format is based on. And so it's going to use what format does instead of messing up what it's been doing up to this point. So look out for this change. If you are using toString, I highly recommend that you go evaluate where you're using it and why, and make sure, to consider moving even before this comes and changes your result. Now, there's no compile warning here, right? So this is just going to subtly change the actual behavior of your program. And so again, don't let anybody tell you we're not willing to actually break your code. Okay. Anything on the string section? Okay, good. Let's move on. So this is still about strings in a way, because format and IO are about strings for sure. So this first one basically is notching up one more level, one little corner case. It's a very small thing in theory, but one of the things that happened after the original format was put in C++20 is in C++23, and I think we made it backward compatible to 20 itself. We put in compile time checking for format arguments, right? The original specification was runtime checking only, so it had safety problems, right? It had the same kind of potential issues that you would see with the C version of print, for example, or printf. But the very nice feature that went in to make the various things checked here, the first, all the first rows in this table show you examples of things that won't compile or will compile correctly. But this last one, where there's basically, this 10 over here, which is a string. Was that really meant to be a string? But somehow or other, that particular case slipped through the cracks. And basically what that is right now is a runtime error. So you will actually get an exception if you write that code currently. So basically the change here is to fix that problem. So that particular one won't compile because that 10 should have been an integer and not a char. And the infrastructure can actually detect that at compile time and tell you properly. So the only thing it should do is fix broken code for you by giving you a compile error and letting you know. Okay. The next one is yet another improvement related to format strings. So who uses format and print? Okay, so we found one feature that's only now seeping in. I mean, who uses std : not fmt : All right, now we're on a small set. Okay, so by the way, as mentioned on the previous slide, FMT didn't have that issue. It was only the standard that had that issue. So when we translated from FMT, which was the basis for format and print, we made a mistake in setting up the wording. Okay, so compile time formatting, runtime formatting. If you have runtime format strings, you've currently had to use the V format. It's very cumbersome in comparison, and it doesn't look like the other API, so it's kind of confusing. So what this change does is actually say, nope, let's allow the regular format by specifying a runtime format type around the string, and basically that signals to the infrastructure that, oh yeah, this is actually a runtime format string. You can't do the compile time checking that you're doing, but at least your interface looks largely the same as if you had put a static format string in that particular item. All right, more corner cases. In C++23, you cannot format a pointer. Bummer, huh? So what? You got to go back to IO streams just for that? That's lousy. Of course, FMT can do it, which is why everybody here is using FMT : So again, an omission, a small edge that needed to be fixed. The next one is another one of those, file system path. Now, file system path is a very complicated thing in and of itself, and it's not without its own controversies. But the main thing to know here is that this can actually now correctly format Unicode paths, which is a requirement on certain platforms. You'll notice on this particular slide, I actually, if you're interested in this, one secret of the standard is this little question mark specifier, which is the debug format for format. And so you can use that in various places, but I threw that in here as something to know about because it's not something that you'd find in many users' guides. Maybe Nico or somebody has a presentation that talks about it, but it just seems like nobody actually knows about this. Okay, so path, that's another one. And then this last one, again, a very simple thing. Print line is another thing. That's the thing to print. And of course, print line required you to pass in an empty set of characters if you didn't want to print anything except for a new line, which I don't know, just feels wrong. So now you can just say print line with no parameters and you're good. All right. Any questions on format? All right. So next, let's talk about optional. So some of this I'll say is a little bit still in the design group. The first one is not, though. This is actually in the working draft. So P3168 gives range support to optional. So why do we want to give range support to optional? Well, the committee had a long conversation about creating new views that could be something like views maybe, or some other set of views that would allow you to have an optionally held object. So like a single view, but maybe it doesn't actually have an object in it. So an optional, essentially. So effectively, the decision was, hey, why don't we just give optional a begin end and make it a range, and that will allow us to use optionals in pipelines and other things within ranges. So this first example is just an example. And by the way, you'll notice that this particular implementation is part of the Beeman project, which if you've been in any of the earlier presentations, and you should go to David's talk tomorrow about what the Beeman project is, we're looking for recruits that want to help us build libraries, learn how to build libraries, and push the standards of library building forward. Okay, so that was my 30-second pitch. I also have stickers up here, so come up and get a sticker afterwards that'll show you how you can get involved. So the first line here, this first section here, that print statement never gets executed because the range for loop is going to evaluate to false. So again, this is a conversion to Boolean sort of construct in that for loop, which range fors do. And in the second one, this will actually print. So this is a very handy capability in a lot of different places. And that one, like I said, is in the working standard. The second one here is optional of a reference type. How many people have used boost optional just for this? Yeah, there's quite a few hands in the room. And so obviously this was one of those things that for whatever reason wasn't included in the optional specification. And so I'm going to move on pretty quickly because I'm running short on time here. But in the past, you would have used a pointer type API for this sort of thing. But it's nice not to have to do that, because if you can use a reference-based thing, then you can use monadic functions. You don't even have to have an if conditional logic here. You can use and then, and if you've got a result, you'll do something, or else if you don't have a result, and handle your error or whatever you want to do. Okay. Containers. Let's move on to that. And the first major change in containers is a new container called in-place vector. This also is a Beeman project that's actively under development today. This is like Boost Static Vector. Folly has one of these. There's a number of these around. Basically, if you look at that, it's like a vector, except for that it has a fixed size that's determined at compile time. That means that the storage, in fact, for the information inside the vector can live inside that object itself. It doesn't have to allocate at all. Now, of course, what you're asking yourself is, well, if I'm able to push back, what happens if I go too far on my pushback here? And the answer is it throws bad alloc, which is interesting for something that can't allocate. But I think the decision there essentially was that that's the exception you would expect if vector ran out of memory. So we would emulate that same API. Now, probably one of the most important things about in-place vector, however, is there's an alternative API that does allow you to avoid the exceptions altogether, and that's these try-in-place APIs, which have several variations here. There's a ranges one, there's just a regular pushback and in-place back. And this isn't even all the overloads, but the point is that you can do this and you will actually get a pointer back to the place where your insert actually failed. So if you're in a range that you're trying to insert the entire range, you'll get back a reference to the place where it failed. So in any case, there are alternatives. This is, again, a very handy data structure in a lot of contexts, especially if you know something about the size of the things that you're going to be utilizing, and will be highly memory efficient. Yes? Does CTAD work with in-place vector? Yes, there are some CTAD overloads, I believe. Yeah, so basically that allows you to write an even nicer set of things. Okay, I'm below 10 minutes here, so let's keep rolling. Next one, span over initializer list. So initializer list makes another appearance in this talk because another edge, right? In C++17 or C++17, we would write this function take like this, right? You would say pass a const reference to a vector event, right? That's how you would write a typical interface. Now, what the core guidelines are telling us to do now is, no, you don't need to write it in terms of vector, write it in terms of span instead. There's only one problem, which is that if you are using an initializer list, like this fourth line of code here, that will fail with span until C++26. It works just fine with vector const ref because initializer list can initialize that just fine. So this is, again, it's a little edge where if you were trying to upgrade your code base to write span, we've done that a lot. It's really nice, actually, because we don't need to know whether it's a vector. It can be a different kind of collection. It could be a boost collection or some other thing. It could be an in-place vector. And span should handle those just fine. Okay, so basically span allows you to write much more generic code without even writing a template. Okay, and the next one, along the lines of Herb's talk, we basically have the at interface for span. So if you want a checked interface on span, you're free to use that. There's a related change in work called views interface at that is not in the working draft. I don't think that's going to make it into 26. I'm not entirely certain. But span at is in the working draft. There's a couple more miscellaneous improvements. Continued things on associative containers. If you're familiar with the transparent concept and not having to convert like a string view to a string for key lookup and so forth, on associative maps. Those are changes that went in 20 and 23. This just finishes the job. Also, somebody wanted to use weak pointers, as a key in a map, so we accommodated them. All right, that's it. All right, 7 minutes. So we're getting, we may not make it through the entire part of the agenda that I was hoping to get to. So the next part, though, I'm actually not going to spend much time on ranges. All right, I got to do the question again, who is actually using ranges? Not as many as some of the other features. Okay, so let me ask this. Is there anybody that doesn't use ranges for just algorithms, the algorithm section of the ranges? Because why aren't you using that? Like, it just cleans up your code and makes it simpler, and that doesn't have anything to do with views and any of that other stuff. So anybody that sold you, and I said this last year in my talk on ranges, anybody that sold you that the whole thing about ranges is views and pipelines, and no. Just use the container, you just need to do a for each or whatever it is. Just use the range algorithm. It's just better. Your code is clearer and simpler. 99% of the time, you're sending the entire collection in to the algorithm anyway. Okay, so there is a plan for 26 ranges. It doesn't look like they're going to make much of this plan, to be honest with you, because there's a lot of papers that are in flight and none of them are done. So, not done papers 7 months from the deadline, not even 7 months, 5 months from the deadline, however long we are, it means that it's going to be difficult. Views concat is the one which is in the working draft already. Slice, take exactly, drop exactly, up to Those are not in the working draft. They're not particularly complicated things. So there's still a chance that some of those will get in. But, you know, who knows? There is another feature in this slide deck that I won't have time to talk about called STL interfaces. That comes from a Boost library. That's actually a thing that allows you to make your own ranges more easily. And so I think that's going to be part of the solution going forward. All right, so views concat. It's a very straightforward idea. In this particular case, I have a number of different things. I have a vector of integers, several vectors of integers. I have an array of integers, and I have a single view that wraps around an integer as well. And with views concat, I can just put those all together. And you'll notice here that I'm using print. I'm not even iterating this loop. I'm just passing it into print. So by the way, if you didn't know, you know, formatting a range in C++23 is a real thing. It just comes out of the box now. And that's a really, really important feature for C++ in my view. Something that people have wanted for I don't know how many decades. So anyway, so this is nice. And of course, reminder with views, the one nice thing about those views is nothing happens until the print facility itself iterates across the view itself. So it's lazy, right? There's no actual calculation that's done until you start iterating across all of them. Okay, and then I'm going to skip forward to a couple of utilities. This next one, again, this is a small thing, but when you need it, you need it. And you can thank Elias, he's sitting in the front room for this feature. But just like with threads, sometimes with a file stream, for example, you might need to do something with a native API. So in the past, you were basically forced to use the native API all the way. And this particular feature allows you to get the native underlying handle of the operating system. It's an opaque type, but then you can pass it into the platform APIs. So again, another small cleanup thing. In this case, the OF stream, of course, is managing the ownership of the open close on the file itself. And then this next one, do we have big users of standard variant here? Yes, variant, very popular. So if you've used variant, you know that right now, you're going to be writing that overload thing, the overload trick, and you're going to have a bunch of lambda overloads that overload all the different types potentially in the variant. So that's what lines 3 through 5 are. Now, the thing to notice about this, right, is standard visit is a free function, and that value, which is actually constructed on line 1, is sort of sitting off there at the end of that line of code. It's not so obvious, basically, what's going on there. So this actually adds a member function called visit to the thing, and you can use your overload, but you can use it in a way where, in my opinion, that's clearer code, and that's basically the reason for this feature. All right, I have 2 minutes left, so I think I'm going to skip over that. Let's see, I'm going to skip over that. I'm going to skip over that. Well, I might have had more time, but I'll mention constexpr all the things, because this is a theme that's been going on now since 2020. And to be honest with you, I think there's another installment. I don't think it's going to get into 2026, but it'll probably be in 2029 at a minimum, where almost everything in the standard library is going to be constexpr. So, but there's a lot of things that are already constexpr. That's very useful if you're doing things at constexpr time. The two small additions here are actually having a sort algorithm that works at constexpr time, which, again, if you're doing any sort of compile time programming, that can be very handy. So that's actually the stable sort algorithm. And the second set of things is a second batch of CMath algorithms. So the first batch went in, I don't know, I think it was either 23, it was 23, I believe. And so there's a lot of mathematics that can now be done, including with this one. Some of the complex overloads, so again, if you're doing mathematics and that sort of thing, at compile time, that's very useful. Okay, and that's it for the talk. There's 14 seconds left for questions. Yeah, standard execution, 14 seconds over here.
Yeah, I was just wondering, the concept of an optional reference is kind of interesting. Like, I guess if you assign to the optional, it reseeds the reference logically?
Yes. Okay. Yes. Oh, yes. So the question was reference in an optional is an interesting concept. If you reassign, it reseats the reference, and that's right. It rebinds the reference, technically, is what it does. Do we have another question? Yeah.
I just want to point out the in-place vector does not do CTAD because you can't deduce the capacity.
Okay, so the comment is that in-place vector does not do CTAD because you cannot deduce the, but you could alias it, see. So you were right, though. I think maybe there isn't. I don't know. I'd have to go back and look at the paper, to be honest with you. I don't know. David, do you know? You're a co-author. He doesn't know. He's a co-author. He doesn't know. There's a lot of words already in the C++ standard from a lot of these features. You can imagine that specification of in-place vector is a non-trivial bit of work. It's probably only, 10 pages of words, 10 pages of English that, specify the behavior, but even that is a very complicated thing in and of itself. So, all right. Anybody else? Okay. I think we're a little bit over time, so I'll say thank you very much, and come get your Beeman stickers and go to David's talk tomorrow. Okay. Thank you very much.